what times what equals the outside, so negative 6. What plus what equals the inside, so negative 5. So what do we use?
Negative 6 and 1.
Negative 6 and 1. Some people say negative 2 and negative 3. Remember, if you draw the blanks, you won't make the mistake. Because if I did negative 2, negative 3, I would realize I got positive 6, and that doesn't work. Right? So you'll catch yourself. In grade 10, this is always the common error that happens. So you do negative 6, positive 1, negative 6, positive 1, try them out. Negative 6 times 1, negative 6. Negative 6 plus 1 equals negative 5. And now we're trying to replace this with this, right? Because negative 5x is the same as negative 6x plus 1x. Bless you. So we can take the negative 5x out, we can throw it away, and we can replace it with that, right? It's the same thing. It's just 2 terms instead of 1, which makes it so we can group, like you learned in grade 10. So that's why your first and last terms do not change. So we get 2x squared. My middle is being replaced with negative 6x plus 1x, and then the negative 3 doesn't change, right? I'm just literally replacing that middle term, for those of you who maybe don't remember your factoring. It'll come back. So we put our brackets around it. We take out a 2 and an x, and we're left with x minus 3. Here I take out, so that's my GCF, that's what I'm left with. Here I can take out a plus 1, and then I'm left with x minus 3. And then we have this one, and we have this one. There's 2 terms. What can I take out of both those terms? X minus 3. That's why we always make those brackets the same. We don't make the brackets the same because it's fun. We make the brackets the same because we GCF a bracket out, right? So we're taking out this red bracket. So we're taking out that x minus 3. And then when I GCF the x minus 3 out, I'm left with 2x plus 1. That's where I get my 2 factors, right? That was grade 10. Grade 11 taught us that when we set it equal to 0, we can solve. Now, what are we actually setting equal to 0? What is this normally? This is a y. So we're literally setting y equal to 0. So we're finding what's when y equals 0? X-intercepts. That's when you're solving. You're finding x-intercepts because you set y equal to 0. So we get x minus 3 equals 0, x equals 3. So I have 3, 0 technically as my answer. And then I have 2x plus 1 equals 0. 2x equals negative 1. X equals negative a half. Negative 1/2 and 0 are my 2 x-intercepts. Right? We learned that last year. So we also then learned last year they could give us the x-intercepts and ask us for the equation. We could work backwards. So we were given the equation, had to find the x-intercepts, or the teacher gave you the x-intercepts, had to find the equation. So an example would be if I gave you x-intercept of, let's say, 4 and 0, and then an x-intercept of negative 2/3 and 0. Those are your 2 x-intercepts given to you by your teacher, and you had to work them backwards, right? So you just undo what you did. That's all you would have to do. Well, I could get my factors back from this, right? Remember, here's my factors. Why are these my factors? Because look, they're my factors. Are they not? They're just my factors. If I plug those factors in to y1, and I plug this into y2, it's the same graph. One's just in factored form, and one's just in standard form, right? Learned that all last year. So if I want, these are x equals 4, and this is x equals negative 2/3. But I want to work my way back to the factors. This one everyone gets right. They'll say, oh, it's x minus 4 equals 0. Cool, that's true. Then they'll say x equals, x plus 2/3 equals 0. That's what I always get in grade 11 when I get to teach it. It always happens. It's wrong, because they'll ask for it in intervals. Here I got negative a half. It was 2x plus 1, right? It wasn't x plus a half, was it? Was the factor x plus a half? No, it was 2x plus 1. So these ones that are fraction answers, you have to remember to work them back into 2 steps, right? It took me 2 steps to go from here to here, right? So I have to do 2 steps to go to my factor. So what are those 2 steps? Well, multiply by 3. So I get 3x equals negative 2. Then what? Add the 2 back. 3x plus 2 equals 0. And then if I want to work my way back to the actual equation, I would just go x minus 4 times 3x minus 2, or 3x plus 2, equals 0. And if I want to go even more back, I just distribute by foiling, first, outer, inner, last, right? And distributing is, you don't have to use FOIL, but when it's a binomial, it's a nice acronym. But really all you're doing is you're multiplying every term in the first bracket by every term in the second bracket, right? Okay. Well, what we're doing today is we're factoring polynomials. That is a polynomial, just so you know, it's a quadratic, right? You'd factored linear ones, they were already done. A linear is like this. 3x plus y equals y, 3x plus 1 equals y. Oh, 3x plus 1 equals 0. Oh, here's my factor. There's one of them. That's it. You get your linear factor when you have a linear. When you have a quadratic, you have to factor to get the 2, right? So we're factoring more. We're going to factor up to degree 5. So we've done degree 1 in grade 10. We did degree 2 in grade 11. And in grade 12, we do 3, 4, and 5 as well. So they're called cubic, quartic, and quintic. So we're factoring polynomials today. We'll start off with cubics. So the first one we're going to factor is x cubed x cubed plus 2x squared minus 5x minus 6. So we can't go, we can't go straight up factoring like we've done before because that only works with degree 2s. We're going to need to be able to factor degree 2 to finish this off, but it's a degree 3, so we have to get there first. Now, these are the steps that I use to factor. Step 1, I always say, can I rocket count? And I want to rocket count my exponents. If I can't, I'm going to have to put a placeholder in there. So what the heck does that mean? Well, I have 3, 2, 1, and what's this one if it doesn't have anything? It's just 0. So did I rocket count just fine? 3, 2, 1, 0? Yes. If the x squared was missing, I just have to put a 0x squared in its spot. Or if the x was missing, I put a 0x in its spot. I have to put placeholders if I'm missing it. If I can't rocket count, I need a placeholder. So more often than not, when people mess up on factoring, it's because they forget to rocket count right off the bat and don't put a placeholder and it doesn't work. Now, factoring results in x-intercepts. We said that, right? That's what we learned last year. Factoring results in x-intercepts. So can I use x-intercepts to help me with factoring? Yeah, x-intercepts are basically one step away from factoring, right? You just work your way back to get your factor. So, number 1, we rocket count. Number 2, we set it up. We do this. Now we're going to make an L like this, and it's going to have 2 rows of numbers. 1 row at the top, 1 row at the bottom. So you can make your L a little longer, like it's not just a really short L, but it's going to have 2 rows of numbers. So I'm going to go like this, and I just put my coefficients in. Coefficients are the numbers in front of the variable. So I go put in a 1, I put in a 2, I put in a -5, I put in a -6. Now if something is a factor, it goes in evenly. Its remainder would be 0. So I could do long division to solve these out. I could do long division, and as long as my remainder came out as 0 with long division like you did in elementary school, then it worked out evenly, correct? Then it is a factor. So I could factor by division, by long division, but synthetic division is easier, so that's what we're doing. This is called synthetic division, instead of doing the big, long division table that everyone dreads, okay? Our key is, if something is a factor, the remainder will be 0, because it goes in evenly, right? Just like 6 is divisible by 3, because if I put a 3 into it, I would get a remainder of 0. If something is a factor of a polynomial, you put it in, you get a remainder of 0, okay? It's a little bit of factor theorem. Now I have to figure out what the heck I'm going to divide by. Now the possible numbers I could divide by and put in the front of here come from your constant. So these are the possible factors. So if I didn't have a calculator, which I'm going to use in a second here, if I wanted to find the possible factors, they're all of the factors of that constant, that number at the back. So in this case it's a 6. So I state all the factors of 6. 1, 2, 3, and 6. And then I do plus or minus. Remember, factors are what multiplies to give you that number. So I do positive, negative of every single one. And then what I would do is I would plug in each one sequentially and see which one gets me a remainder of 0. Because if it got me a remainder of 0, I could use it. But ultimately, what am I trying to do? I'm trying to find a factor that goes in evenly so I get a remainder of 0. We agree? So can everyone type this into your calculator? X cubed plus 2x squared minus 5x minus 6. You don't need the x to the 0. Everyone type it in. Press zoom and then 6, just so you can see what it looks like. Zoom 6 just resets your window to -10, 10, -10, 10, just in case you had a wonky window. You don't have to press it every single time. You can just press graph, right? I just did zoom 6 because I don't know where all you guys are sitting with your graphs in front of you. In front of you, you should have like a sideways S. Do you have that? Looks like cubic, it's like this. It should be on your graph like that. If it's not, you didn't put your exponents in properly. Did everyone get it to show up on their calculators? Okay. What did I tell you? I told you that x-intercepts can work their way back to a factor, right? We just talked about that. I took these x-intercepts, boom, boom, and I worked them back to factors, did I not? So can I not just look for an x-intercept in my calculator to work it back to a factor? Where can I find x-intercepts on my calculator? Second graph. Go to my table. And what do I look for when I'm trying to find x-intercepts? Nope. Y equals 0. So I'm going to look for an x-intercept on my calc. Because I could put in 1, -1, 2, -2, 3, -3, 6, -6. I could put that in and try them all out and get a 0, right, for my remainder. But this is another way that guarantees it. So I always use my lowest x-intercept, so the most negative or the smallest. So what is the lowest one on there? You can use any of them. I use the lowest so we're all doing the same math. What's the lowest one on the table? Remember your table? I didn't know this till last year. Some people don't know how to move the table. You can arrow up and arrow down. The table extends, right? It's not just short. Yeah. -6. So I'm going to put x equals -6. Is that it? I think it's 5, isn't it? Is it 2, 1? What is it? 3. You know what -6 is? 3, -3 times 2, which is what he meant, which is -3. Same thing.
I thought you meant go from lowest to highest.
Oh, you meant off of these ones. No, I meant off your calculator. Like on your calculator, if you look at your table, the lowest one is -3.
Oh, are you talking about for your x one?
Yeah. Okay. So that is my x-intercept, and I use my x-intercept on my synthetic division table. Okay? But I'm trying to factor. We agree? So what is x equals -3 as a factor? Anyone know? X plus 3. What's the great thing about factoring? You should know if you're completely correct at the end and be happy or sad. There's no in between. Because what we're trying to do is, down here I write x cubed plus 2x squared minus 5x minus 6. We're just trying to find the factored form of that, correct? So I'll be able to type this into y1, the factored form into y2, and I should get the same graph. If I don't, I messed up, because it's just the factored form of it. One's standard, one's factored. Nothing different. Like last year, when you found factored form for a quadratic, you should be able to put in the quadratic and the factored form. You should have got the same graph. You should have known to be happy or to be sad. So I bring my factor down here. It's x plus 3. Okay? Now, synthetic division is going to seem overwhelming for the first two examples, but it's actually the easiest thing to do since like sliced bread, like cutting bread. I don't even know why I compared that. But it is easy. It seems overwhelming at first, but as long as you can find an x-intercept in your calculator, and then you can multiply, add, multiply, add, multiply, add, multiply, add until you get a 0, you can do synthetic division. That's all it is. So, our first step, once we get this, okay, is to drop the 1. After this moment, we will multiply, add until we're done. Now, I'm going to draw arrows to show you where it goes. I do that for one example because it looks really hella confusing with all of the arrows. But I do the arrows so that you can follow it in case you forget. Okay? So we're going to multiply, add, multiply, add, multiply, add. So first thing we're going to do is multiply. -3 times 1 is? Okay, and it brings it up here. Now I multiplied, so what am I going to do next? Multiply, add, multiply, add, multiply, add. What am I going to do next? Add it. So 2 plus -3 is? -1. Okay, I just added. So what am I going to do next? Multiply. -3 times -1 is? positive 3. I've just finished multiplying, so I'm going to add. Negative 5 plus 3 is? Negative 2. I just finished adding, so I'm going to multiply. Negative 3 and negative 2 is? 6. I just finished multiplying, so now I'm going to. And what did I get?
0.
Which is my remainder, which is what I need. If you do not get 0, you either messed up in just your mathematics, or you did not grab an x-intercept. You possibly people grab y-intercepts by accident. So just watch yourself. If you don't get a remainder of 0, it's not a factor, because the definition of a factor is the remainder is 0. It goes in evenly. Okay? Now I took out one factor. Look down here, guys. I have one factor out. This is an x to the 1. How many more x's am I going to need to get an x to the 3? 2. 2 more. I already have 1. I'm going to need 2 more. We agree? So if I took an x out already, what is this here going to be? Because I took the x's off. This is going to be 1x squared minus 1x minus 2. Because I pulled an x out, it's not cubic anymore. This is quadratic. I just took these numbers here. It's a quadratic now. That's grade 11. How do I factor that? You factor it. That's it. Yeah, product sum. You're going to learn that when there's a 1 in front, you should rejoice. Because when there's a 1 in front of your polynomial that they give you, the 1's going to drop down the whole time. Your end result is going to be product sum and not decomp. If there's a 2 here, a 2 would drop down. I'd end up with a 2 here, and then I have to do decomp, right? So you'll learn to like polynomials with leading coefficients of 1. So I factor this and I say what times what equals the outside one, so negative 2. What plus what equals negative 1. What do we get?
Negative 2, 1.
And I don't have to do decomp. I can go right to brackets because I have a positive 1. So I get x minus 2 and x plus 1. And those factors join these ones. X minus 2, x plus 1. And if I distributed these all together, I'd get x cubed, wouldn't I? So at maximum, an x cubed can have at maximum 3 factors, right? It can't have 4. That would give me an x to the 4. This is an x to the 3. Now, I want you guys, so this is the factor form here. I'm going to box it. But what do I want you to do? I want you to type into y1 the original. X cubed plus 2x squared minus 5x minus 6. And then into your y2, I want you to type in x plus 3, x minus 2, x plus 1. Why would I make you type them both in? Because they're the exact same graph. Now, if you do only this and you press graph, it'll draw one graph and you won't know if it drew both graphs on top of each other or if it just drew one and one way off to the side outside of your screen, right? So this is why I told you guys, if you don't have the colored ones, please make this thicker. And the reason why that'll do that is your y1 will be drawn thin, your y2 will be drawn thick over top of it, and you'll actually see that it's the same graph, right? You walk away feeling like, you know, you rule the world. You know it's right, you move on, right? So when I ask you to factor something, I want factors. And factors are those brackets. And if you don't know that they're those brackets, think when they ask me to factor, I get brackets. Ah, those are the factors, right? Okay. Number 2. If we didn't use our calculator, guys, we would have to plug in 1, see if we get 0, plug in negative 1, see if we get 0, plug in 2, see if we get 0, plug in negative 2, see if we get 0. And we'd plug in all the possible ones until we actually get 0, and then we'd use that one. If we didn't have our calculator to look for x-intercepts, we'd plug in these babies over here and just see till we get a 0. Okay? So you'd have to just guess and check. Okay, number 2, I want you to try and factor this one. X cubed plus 9x squared plus 23x plus 15. Okay, so the first thing we have to do is check if we can count down. I'm going to go through it because some people are struggling, which is okay. I've taught one thing, so I can't expect that you would all know how to do it perfectly. So we have 1, 9, 23, and 15, and I can write them all down because it's 3, 2, 1, 0 technically. If I want to state the possible factors, they would be of the factors of 15. So plus or minus 1, plus or minus 2, that's a lie, 3, plus or minus 5, plus or minus 15. When you go to your calculator, what's the lowest one? What's the lowest x-intercept? Because that's what I'm looking for. Negative 5. So I'm going to say x equals negative 5. And then off to the side, not within this, so I don't get it confused, I'm going to put the factor, which is x plus 5. And then at the very end, I'm going to have the equation, x cubed plus 9x squared. Why do I do this now? So you don't forget the factor. 23x plus 15 equals, and I write this factor right away because a lot of people will forget to write this one. So I go x plus 5. Okay, now my steps are drop the number, multiply the outside, add the inside, multiply the outside, add the inside, multiply the outside, add the inside. So I go negative 5 times 1 is? Negative 5. Then I add the inside. 9 plus negative 5 is? 4. Then I multiply the outside. Negative 5 times 4 is? Negative 20. Then I add the inside. 3 plus negative 20 is? 3. Then I multiply the outside. Negative 5 times 3 is negative 15. Then I add the inside, which is 0, and I need it to be a 0. So I box it. Now, if that was an x cubed, this bottom is going to be a what? X. If this was an x cubed, this is going to be an x squared, because it's just one less, right? I took a factor out. So this becomes 1x squared plus 4x plus 3. And then I have to factor it. What multiplies to give me 3 and adds to give me 4. 3 and 1. You were right. So I get x plus 3, x plus 1. And those go down here. And this is my answer. Last one, we'll do it together. Factor x cubed minus 27x plus 10. If I give this on a test, most people will get stuck because they forget number 1. What's the number 1 step you have to do? Rocket count. Can I? 310. No, so I'm missing this x squared. Yeah, so I go x cubed plus 0x squared minus 27x plus 10. And then the possible x-intercept, so if I didn't have my calculator, possible factors or x-intercepts would be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. So you type that one into your calculator. You don't have to put the 0 in your calculator, you just need it for your synthetic division. But if you put it in, it won't hurt. What do you get as the lowest one? Well, the only one. X equals? Pardon? 5? So then it's x minus 5 is my factor. So I have x cubed minus 27x plus 10 equals x minus 5. And then I drop down my 1. Multiply outside, add inside. So 5 times 1 is 5. Add it. 5. Multiply. 5 times 5 is 25. Add it. Negative 2. Multiply. 5 times negative 2 is negative 10. Add it is 0. This is actually the best thing ever because I have 1x squared plus 5x minus 2. What multiplies to give me negative 2 and adds to give me 5? Nothing in the world. I can't factor it. So if I can't factor it, that is my factor. It is just x squared plus 5x minus 2. I can't factor it any further. That is the factor. So these are called linear factors because it would make a line. So that's the linear factor. What would this one be, do you suppose? Quadratic factor. Sometimes they just ask you for the quadratic factor.